In this lecture video, we're going to add to our understanding of the normal curve by talking about the location of the quartiles. The first quartile, or Q1, corresponds to the 25th percentile. That's the data value such that 25% of all data values are less than or equal to that value, which also means that 75% of all of the data values are greater than or equal to that data value. The second quartile, or Q2, corresponds to the 50th percentile, which is also the same as the median, and in the case of the normal curve, the same as the mean. The third quartile, or Q3, corresponds to the 75th percentile. That's the data value such that 75% of the data values are less than or equal to that value, and 25% of the data values are greater than or equal to that value. We can calculate our quartiles using percentiles, but we can also estimate the first and third quartiles by using the mean and the standard deviation. If the data is normally distributed, we have what we call the magic number, 0.675 to be exact. If we take the standard deviation and multiply it by 0.675, that's how far from the mean the first and third quartiles are approximately located. In other words, if we know the mean, we can add the standard deviation times 0.675 and find an approximation for the third quartile. We can also take the mean and subtract the standard deviation times 0.675 to find an approximate location for the first quartile. Let's take a look at an example. In this example, we're going to use the normal curve and the information labeled on it to find the median, standard deviation, and first and third quartiles. First, we start with the median. Since this is a perfectly normal distribution, the median is the same as the mean, which is right in the middle of the data. This should also be the center between the 2 points of inflection. And with one point of inflection at 450 centimeters and the other at 560 centimeters, we can find the median by finding halfway between those two values. To find the middle of two values, we add them together and divide by 2. This tells us that the median is 505 centimeters, which is also the mean. Now let's find the standard deviation for this distribution. We know that the standard deviation can be approximated using the distance between the axis of symmetry and the location of a point of inflection. The axis of symmetry is located at 505 centimeters, and the location of one of our points of inflection is at 560 centimeters. So we can approximate the standard deviation sigma by finding the difference between 560 and 505. In other words, the standard deviation is about 55 centimeters. Now that we know the median, mean, and standard deviation, let's find the first and third quartiles of this distribution, and we'll round to the nearest centimeter. We know that the distance from the mean to the first and third quartiles can be approximated by taking the standard deviation and multiplying it by 0.675. In our example, we have a standard deviation of 55 centimeters, and if we multiply that by 0.675, we get approximately 37 centimeters, rounding to the nearest centimeter. That means that the distance from the mean to the first and third quartiles is 37 centimeters. To find the third quartile, Q3, we need to take the mean and add to that the standard deviation times 0.675. In our example, we found the mean to be 505 centimeters. And adding 37 centimeters, we find that the third quartile is approximately equal to 542 centimeters. To find an approximation for the first quartile, Q1, we need to take the mean and subtract the standard deviation times 0.675. In this example, that's 505 centimeters minus 37 centimeters, which gives us an approximation for Q3 of 468 centimeters. So we've used the mean and the standard deviation to find the first and third quartiles. Let's take a look at a different type of example. In this example, we are given a normal distribution with a first quartile equal to 229 and a third quartile equal to 391. From this information, we first will find the mean of the distribution. Let's label what we know. We know that the first quartile is 229, and the third quartile is 391. Since this data set is normally distributed, we expect the mean to be the same as the median, which is the same as the 50th percentile, which should be located precisely in the middle of the first and third quartiles. And the middle of 229 and 391 we can find by adding them together and dividing by 2, which is exactly 310. Now, from this information, we're going to find the standard deviation and round to the nearest integer. We know that the distance from the mean to the first or third quartiles can be approximated by the standard deviation multiplied by 0.675. So if we know the distance between the mean and either the first or third quartile, we can use that to approximate the standard deviation. This distance from the mean to the third quartile is 391 minus 310, or 81. So the standard deviation times 0.675 we can set equal to 81. And dividing both sides by 0.675, we have that the standard deviation is equal to 81 divided by 0.675, which is equal to 120. So now in this example, we were able to take values for the first and third quartiles and figure out the mean and standard deviation. That concludes this lecture video on the normal curve and quartiles.